Hello, audience members.
I am Li Bing. Welcome to today's program.
I'm Joe Li. Hello, everybody.
Today's program, we're going to discuss earthquakes. This is a very important topic. The underground in Los Angeles is not stable. It's always trembling.
Yes. Ha ha ha. They scare me silly.
About 1 month ago, we invited an earthquake specialist from the University of Southern California to talk to us about earthquakes in Taiwan. Today, we have Dr. Da-Jiang Liu with us. He is a physicist who worked in the Chinese Academy of Sciences. He will discuss the topic of earthquakes with us today.
Mr. Liu, how are you?
Oh, I'm good. How are you? According to new scientific research, we usually aren't able to predict when earthquakes will hit. Your opinions seem to be completely different. Correct. It is my belief that we can predict earthquakes. Why is that? My extensive research conducted 20 years ago in the Maiyun Reservoir Earthquake Station near Beijing showed that earthquakes can be predicted completely. They are not only predictable, but in some cases they can be predicted more accurately than even weather forecasts.
Better than weather forecasts?
Yes. Recently I published an article entitled, "Why Did I Say Earthquake Prediction May Be More Accurate Than Weather Forecasts?" Why? Ha 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 ha. Where did you get it? Can you talk about it? How did you do research back then? Alright, I'll talk about it. In the beginning, I worked in the Physics Institute Chinese Academy of Sciences to study lasers. On July 28, 1976, a large earthquake hit in Tangshan. At that time, we had just received an instrument called Laser Lock Strainometer. Soon this instrument was carried and installed into a cave near the Maiyun Reservoir to test a strain of bedrock and to see if there is any kind of precursor which would happen before an earthquake.
We didn't know how to predict earthquakes after we installed the instrument.
Since I was a physicist, I never studied seismology science before. I didn't understand it. Geology, right, geology and seismology. Let it record by itself and see what would be recorded. By doing this, we are able to record some jumps. So jumps with periodicity. Usually the first jump would be followed by a second one before an earthquake. As you know, many kinds of natural phenomena have periodicity. For example, one revolution of the Earth rounding the Earth takes about a year per revolution. We consider that the earthquake could be predicted by its precursors, then the prediction may be accurate when its precursors have periodicity. It is very difficult to do predictions if there is no rule. According to this idea, we started to observe if there was periodicity or not. Then we tried to predict after we got the precursors. First precursor, second precursor, and made calculations. For the first time, we made a joke, said that if X times time times the minute in some day, an earthquake would happen. Afterward, it really happened. The time difference only was 33 minutes. Wow, that's so accurate. Right. The first one was put down in writing. This was the calculation. Then I was thinking, it's very strange. How are the jumps related to an earthquake? Oh, you refer to the jumps that came from the bedrock motion, namely a recorded signal. Signal? Yes, this kind of signal was a jump at first. Then it stayed there for a while, and afterward became very quiet. It's kind of a sudden change precursor. Did you use a laser instrument? Yes, the Laser Lock Strainometer. It is an interferometer. One of its arms uses a quartz tube as a standard arm. Its length does not change under the conditions of constant temperature and constant humidity in the cave. Another arm acted as a strain measuring arm. Its length changed following the change of distance between the two walls of the cave. The signal of the earthquake precursor could be recorded if the distance between the two walls of the cave was changed under the action of a stress field. Oh, so if we use our hands to push the wall of the cave, the jump can be recorded by this instrument. Oh, it's so weak and could still have a response? We often see a kind of instrument, seismography, at the earthquake observation station, which can record earthquake waves. What's the difference between your laser and theirs? Oh, my laser phase stock stainometer can not only record earthquake waves, it's similar with seismography in this function, but also can record earthquake precursors. Regular seismography cannot record precursors. Oh. So at this point, it's different. Yes. Science needs evidence to convince people that the findings are true. Let us see witnesses and exhibits. What predictions have you made? Here we see two letters. These are witnesses that Professor Da Jiang Lu, physicist of Chinese Academy of Science, talked about today. Right? Right. What was the situation at that time? The headquarters of the General Staff of the Chinese People's Liberation Army wrote this letter. Let me introduce myself briefly. Soon after I started the research, the earthquake predictions, I found relatively accurate precursors related to earthquakes. So I made some trial predictions. Afterwards, the headquarters of the General Staff realized that my earthquake prediction report was very important, so they contacted me. At that time, the telephone for long distance call was old. It only got through by hand. Right, I remember. It was not easy to make phone calls from the Maiyun Reservoir to Beijing. I had to ask the operator to convey the information. I spent a lot of time to report observation results and prediction contents. Of course, that was 20 years ago. After that, the headquarters of the General Staff knew that they had to set up an Army phone line from Maiyun Reservoir for us to the headquarters of the General Staff. In this case, we could make phone calls directly to the headquarters. They needed earthquake information, earthquake prediction information. We needed them to support the communication. So we had good cooperation. Around the time that you made predictions around the Maiyun Reservoir, how far at most from your station would these earthquakes, which you could supervise and predict, actually happen? Oh, well, that's a very good question, actually, because all the people ask the same question. People will ask me, with this instrument, can you predict earthquakes in Japan, even if it's located in America? What's the scope in which we can supervise? The distance in which the earthquakes could be predicted is not constant. The crustal stress is relatively high near the observation station when a near earthquake is gestating. During this period, the earthquake, which is far away from the station, could be predicted under the action of global stress field. I predicted the earthquake in the Ogasawara Isles of Japan successfully, which was 2,000 kilometers away from my station, and the earthquake in Alaska successfully, which was 6,000 kilometers away from my station. Do you